Excellent. So let's kick off the webinar. I'm super happy to have you all here today with us. And it's a very exciting moment for us because this is we are kicking off our webinar series, and this is the first webinar in our series organized by Clofio along with Cloud Mahut team. Super happy about, both teams coming together in collaboration and organizing this. So I'm hoping that you all are able to see my screen. And our webinars in this webinar series, we wanted to focus on helping everyone understand their cloud cost problems, right? So with that theme, we started our first webinar on cloud cost accidents and how to prevent them. So while working with our customers, we have been seeing a lot of different issues people face with their cloud cost. And we wanted to take up the most common one among them and share it with you so that you can learn from their mistakes and hopefully not to do that yourself, right? So that has been the agenda for our discussions. Before we jump into the content, let's just start with a short round of introduction. So myself, Atanu Roy, I'm the co-founder and CEO of Clofio. Today I'll be the speaker of this webinar. Along with me, I have Amber Bokare, who is the co-founder and CEO of Clofio. He will be the host and moderator of this discussion. So while I speak, if you have any issues, feel free to post it in the Q&A section. Amber will be looking at it and help you with that. Uh, so, like probably a little bit of our journey would make sense here. How we came forward. We both spent more than a decade, in industry, helping with working with multiple enterprises, build their enterprise tech, have built multiple products, managed engineering teams. And late last year, we started this journey of Clofio. And our motto has been to help people with their cloud cost problems, right? So we'll keep what we do aside, but we wanted to, in last 1.5 years, what we learned about, the kind of cloud cost mistakes people are making, we wanted to share that with you. And our today's agenda is to focus on that. So let's move on. Before I think, start with cloud cost accidents and all the other things, let's first talk about why cloud cost. Why cloud cost is super important, why we should talk about it, right? So let me talk about a few stats here. Before that, probably I'll quickly, walk you through the agenda so that you have the, the total, webinar in mind. So we are going to start with, as I mentioned, why cloud cost is important. We are also going to look at how cloud platforms basically bill you, right? What is their cloud pricing model? We are going to delve into that. Then we are going to talk about the 5 common mistakes we are seeing across our customers. So we are going to dig into each of them. We are going to talk about what kind of mistakes people have made. And most importantly, we are also going to share the playbook for you, how you can basically avoid that kind of mistake, right? At the very end, we are going to share a small cheat sheet about how you can, avoid these kind of mistakes overall in your organization while you are working with cloud cost. And eventually, we are going to take up the, Q&As from you, looking forward to understand your problems, answer them, help you with whatever knowledge we have. So with that, let's start our agenda. First, why cloud cost, right? Why it is a super important topic. A few stats. By 2027, cloud cost is going to reach $1.5 trillion across the globe, right? Today, it is almost approximately $800 billion across public cloud, private cloud. By 2027, it's going to reach 1.5 trillion, right? So just to give you a context, by 2027, India's economy is most possibly going to be, $5 trillion. So nearly 30% of India's economy is going into just cloud spend, right? Not only that, SMBs and startups are roughly 30% of their revenue is going into cloud, because these days, most of the organizations are tech driven. And most of these products are being born in cloud, right? People are building their tech on top of cloud. And the overall revenue, they are spending almost 30% of it into their cloud spend, right? But more interestingly, if you go towards, let's say, larger organization, enterprises, 30% of their cloud cost goes into waste. So this 35% does not contribute into their business goal. They are spending the money, but they are not getting any ROI out of it. Probably a little bit of interesting facts on Indian context, right? Uh, the cloud cost growth in India is much higher than the around the globe, right? Because of so many startups coming in India, so many exciting let's say unicorns coming in. There are so many success stories around us. In India, the growth of cloud cost is approximately 40% compared to over the globe, which is like 23%. Two very famous companies, you must be knowing them, Zomato and Flipkart. Can you imagine they are spending 500 crore INR every year in their cloud spend, right? Huge. So you can imagine in a bigger organization, if we, merge the stat, 35% of that going in waste, and they are spending like, 500 to 1000 crore, you can imagine how much is at stake here, right? So let's see how this actually works. We will start with the cloud pricing model, how cloud pricing works and how these the entire problem of cloud cost accidents come in, right? You all might be very much aware of the cloud pricing model, which is called consumption based pricing, in other words pay as you go, PAYC model. And this is the culprit of the entire problem starting up, right? Earlier days, maybe 5 to 10 years back, a lot of people were doing in-house data centers. So you would either buy or build a data center or rent out from someone, and you have a predictability of your cost that, hey, this much I invest to build a data center or this much I pay every month as a rent. So you have a capacity, you pay for it. There is nothing going up or down. But with public clouds or any kind of cloud offerings these days, it has become entirely consumption based. So you can maybe spend $100 a month, you can spend $10 a month, you can probably spend $100,000 a month in cloud. So it goes up or down based on how much you consume in your cloud platforms, right? Let's dig a little bit into it, how this cloud pricing works. Typically, cloud platforms will use two different ways of billing you. One is purely on time access. So let's take an example. If you are using, typically it works for all the compute resources, right? So if you are using, for example, a M5 large EC2 instance, it is going to cost you $70 per month. So, and it is, billed hourly. So every hour you run, you basically end up paying some money. Compared to that, there is another class of way of billing you, which is volume plus time. Typically, your storage cost or the data transfer cost. So if you are storing 1 TB of data in S3, you are going to pay $23 per month, right? In our entire webinar today, we are going to take a lot of example from AWS because that has been a most commonly used cloud platform. But if you are using Azure or GCP, the concepts and the ideas are exactly the same, right? So feel free maybe in a Q&A section if you have any Azure or GCP specific question, we can take that up. So coming back to the topic, cloud pricing, right? So it is done in two different dimensions. One is time, another one is time plus volume. Another interesting factor of cloud cost is the commitment, right? We all have heard about cloud platforms commoditizing infrastructure for us. And as like any commodities, wholesale pricing comes in, right? And cloud commitments is basically wholesale pricing. You commit to spend something in bulk as against you get a discount, right? Commitment again works in two different ways. One is purely on time basis where you say that, hey, I am going to use a certain capacity for a year or 3 year. 1 year or 3 year is typically, two different time frames where you purchase, you purchase your commitments. The other one is spend-based commitment, where you say that, hey, I'm going to spend X amount of dollar per hour until 1 year or 3 year, right? Now, let's spend a little bit of time in understanding these two different, these two things, right? So once you say that, hey, I am doing a time-based commitment, you basically commit for a piece of infrastructure, which you cannot change, and you are going to run that infrastructure for a certain time. Whereas on the spend-based commitment, you say that, hey, I am going to spend X amount of dollar, where you have flexibility of choosing what infrastructure you are going to run as long as you spend that amount of dollars. So maybe, you can spend 1 unit of $10 or maybe, 4 unit of $2.5. It's one thing or same. What is the benefit of disadvantages of one over another? We have a specific topic on that. We are going to come in, in the later part of the video. So we are going to, jump into the core part of our discussion today. 5 examples of how cloud cost accidents happen. Before we jump into the examples, I'm just going to talk, talk a little bit about what we mean by cloud cost accidents, right? While working with a lot of our customers, we have seen that people are making certain mistakes for which they end up paying more money than they should, right? And when you pay more money than you should, you basically get a bad ROI, right? So what you could probably achieve in $100, you are paying $150 or $200. So that extra amount of your money paying to the cloud platform is not contributing in your business goals, right? So we are going to talk about 5 such examples where we have very commonly seen people making mistakes and paying more than what they are supposed to. Right? So that's what we mean by cloud cost accidents, and we are going to dig into them one by one. So the very first example we are going to take is over-provisioned resource, and I'm pretty sure you must have come through it in your journey as well. The most common way of losing money, right? Over-provisioned resource. So let's take a, let's talk about why over-provisioned resource happens. And a very common, let's say, issue people basically, misunderstand or often miss, even though they know, they miss this fact. In cloud, you are billed for your provisioned resource, not utilized capacity, right? Which means is that if you are running a, virtual machine, maybe, you are running a, let's say, 2x large machine compared to a large machine. If you are using 20% of a 2x large machine compared to 40% of a large machine, basically your utilization is the same, but you are paying double the money, right? So it's a very common, problem across a lot of customers. Typically, what we have seen is that while deploying your infrastructure, optimistically, engineers deploy bigger than what they need. Often that stems from the fact that they do not know what they need, right? So optimistically, they, they provision a bigger resource in hope that by provisioning bigger resource, they will not have any bottleneck during their researches and etc. But more commonly, we see that they use only a fraction of that resource and end up losing money for the rest of the capacity, which they are not using, right? Over-provisioned resource is one of the most common way of, overspending. And we are going to talk about what you should do to, stop overspending, right? Very simple. And all the playbook we are going to share with you are not rocket science, right? These are very simple thumb rules which you can follow, and you can by using those best practices you can always save money. Over provisioned resource, what you can do. First and foremost, always start with small and grow as you need. Unless you know exactly what you need, that you probably are doing some experiment, maybe you are running some machine learning model, or you are running some kind of, let's say, big fat server. Unless and until you exactly know that, hey, I need, let's say, 4 core of server, 8 GB of RAM for XYZ reason, always start with small. If you are doing your research, it is a development environment. We strongly suggest using burstable instance if it is a if it is a database or EC2, so which is like T3 or T3A classes. And if you want to start with small, 2 core 4 GB RAM is a decent way of where you can start, right? If you are running even lighter infrastructure, just like you can always go for 1 core 2 GB or something like that. But 2 core 4 CPU, roughly it will cost you around $20, roughly $20 per month. That is a good starting point. Now, once you have started with that, the the approach is to look at your infrastructure, keep an eye on your resource spend, your utilization of your resources, and whenever you are hitting 80%, if you are hitting your you are consuming 80% of your resources continuously, that's the time to scale, right? And that is the way you are going to figure out how to find the right size of your infrastructure. This is typically called the right sizing exercise, right? So if you have already deployed your infrastructure, identify what is the actual utilization of the resources and downsize your resources. Typically, a good percentage of resource utilization is 60 to 80%. That's what you should target. Anything below 50% is underutilized, so you should target to downsize that and save cost. If it is the very beginning of your journey, you are starting just with your infrastructure, start with small, and as you grow, keep increasing your infrastructure until you find the right combination. So that was about the over provisioned resources. Let's move on to the next one. Idle resources, the cousin brother of oversized resources, right? A very common example of why idle resources happens, right? And idle resources is flat, right? Your money is going down the drain. Simple. So you do not utilize your infrastructure. You are making someone else rich. You are paying the money, but you are not using it. Let's try to understand a very common, a few very common example of why idle resources happen. Very simple. You are starting a particular resource, but you are, let's say, not shutting them down, right? So these are your experimental researches, which maybe, in this sprint, you started some infrastructure, which you are going to use for your, let's say, sprint development. At the end of the sprint, you did not shut them down, right? So those things keep incurring you cost. Dev and test environment, another very common example where it is not, per se, let's say, something which you do not use, you use that, but you use that partially, right? So those are also, some kind of examples where your infrastructure lies idle for long amount of time. Beyond that, a very common example in the production system is the deprecated resource. People upgrade from one set of infrastructure. Maybe you were running, let's say, big servers before. Now your architecture moved to serverless, but I forgot to clean up my, my earlier resources. Overall, idle resources, a big part of idle resources is contributed by human errors. I forgot to delete, right? So this is, and that's totally fine, right? People makes mistake, and this happens. But eventually, the bottom line is that you keep paying for something which you do not use. So let's take a look at your playbook, right? What you can do about tackling idle resources. A very large part of your idle resource consumption will be contributed by dev and test infrastructure, right? So these are big fat infrastructure which you use only during your work hours, right? Morning 9 a.m. I log in, I start using the infrastructure. Maybe in the evening 5 or 6 I log out. Till next day morning, the resource is sitting idle. Over the weekend, the resource is sitting idle. You can automate the start and stop of this infrastructure. You can do it yourself. There are a whole bunch of open source projects available right on the internet who can help you do that. You can leverage default capabilities of AWS. AWS provides templates. Or if you are using any kind of, let's say, cost optimization tools, they also provide similar capabilities. Make sure to use that. Automate the start and stop of your infrastructure. And now I'm going to tell you a stat. If you are automating the start and stop of your dev and test infrastructure and you are running them only during the working hours, you can save 66% of your cost. 66%, that's massive, right? So 2/3 of your cost will be saved if you are just running them 8 to 10 hours a day and not over the weekend. So make sure to leverage that, to automate your start and stop. Beyond that, your idle resources, which are deprecated, which are not being attended, make sure to establish a cadence in your practice. We suggest to do this at least once a week. If you can do that more frequently, there is nothing good than that. But make sure to look at your inventory and identify and kill any infrastructure which you are not using, right? So make a habit in your team to build these kind of regular cost reviews and clean up. And when you are cleaning up, what one additional thing we commonly come across is that, human intention, right? We fear to delete things. We fear to clean things up. Hey, what if I need it later on? Hey, what if I need that data I did for my POC? So I'll just keep it running. No, you can always take a backup. If it is an EC2 instance, you can just keep the EVS volume and shut down the instance. If it is a database, you can take a snapshot, shut down, delete the database, right? So there is always a way. Do not keep them hanging. Either shut them down or backup and clean. That's the strategy for you to tackle the idle instances. Let's move to the next one. Commitments, right? We talked about commitments in the beginning of how cloud pricing works, and we are going to talk about how commitment can go wrong, correct? And we believe this. Poorly taken up commitment is way more worse than actually not having a commitment. We are going to talk about that. First, let's understand what is commitment. We talked about this before. It's a wholesale pricing, right? You commit that, hey, I'm going to use X amount of capacity for a certain amount of time. As against that, you get a, let's say, reduced bill, right? So approximately 60 to 70%, exactly 72% you can get at the highest tier of cost savings you can do by buying the commitment. But a very big problem of commitment is that if you are purchasing a commitment in AWS world, it is the reserved instances or the compute savings plan. If you are purchasing reserved instances, then you are locked into that reserved instance, right? So you commit that, hey, I'm going to use, let's say, C5X large for a year. So once you have made that commitment, regardless whether you use that C5X large or not, whether it is sitting idle, whether even you have shut that down, still you are going to pay for that money. AWS is ruthless, right? If once you make a commitment, they hold you for your commitment. So unless and until you are very sure that a lot, this is something we have seen that, a lot of people sees commitment as a low-hanging, cost savings opportunity that, hey, I purchase a commitment and then I get save 66% of my, cost, right? But you do not see the fact that once I purchase, I cannot go back, right? One other, very important fact is that in US market, if you are a US entity, there is a way of reselling your commitments in the secondary market, right? You can basically sell it, you can bid for it and sell it. But for us, the entities registered in India who are part of AWS, Indian entity, you cannot participate in that sale, right? So you are entirely locked out. So unless and until you are very sure about your, commitments, do not purchase a commitment. So let's take a look at, what is your playbook here? As I am saying, do not rush to your commitment. A very good strategy of identifying your commitment is first running your infrastructure in your dev environment. Understand what is your spend pattern, which we have talked about in our first point, right? Right sizing your resources. First, right size your resources. First, understand what is your need, what you are going to run your infrastructure on, the capacity, then make a purchase, right? If you are very sure that, hey, this is this is the, it is a X large instance or 2X large instance, and this is what I get, for example, 60 to 80% of my utilization on this particular instance size, then make a commitment. Do not make a commitment before understanding your workload first. You are going to, pay money which you do not use. Part one. Second part, for all the cloud platforms, GCP, AWS, Azure, there is another way of committing is spend-based commitment, right? Where you do not lock into a specific type of infrastructure rather than you commit on number of dollars, right? This is a far better way of committing if you are a fast growing startup, right? So typically what we have seen is that in a fast growing startup, your need changes very quickly. Today you are running on a, let's say, X large instance. Tomorrow you are going to, let's say, probably, your, let's say, workload going to increase. You are either going to scale up or scale out. Or maybe, you are moving entirely into a, let's say, Kubernetes cluster or some kind of serverless. So these kind of technical changes happen super fast in a fast growing company, right? If you are typically a startup or let's say scale up. In this kind of landscape, if you are working for a startup or scale up, you need to be more careful while purchasing commitments. Spend-based commitment is a far better option for you. Why? Because you can move across different instance classes. You can basically play with your infrastructure. You can right size it. You can move to a different instance class while still making sure your commitments are met. And another tip, whenever you are making spend-based commitment, we always suggest to do it in a staggered manner. So if you are understanding that as of today, your, let's say your total spend, on-demand spend is, let's say, $100, first make a commitment of 30 to 50% of it. Consume it properly, then make another purchase. Do not make a 100% of let's say purchase. What happens is that whenever you do a cost exercise, cost optimization exercise, typically your cost goes down by 20 to 30%. But if you already have made 100% of cost commitment, you are going to lose that 30%, right? Which you have already committed. So eventually all the cost optimization exercises are goes to it does not affect into a cost savings, right? So whenever you are making any kind of commitment, so two things, I'm going to repeat this thing because this is a long term let's say effect of this these commitments. One, until you have right sized your infrastructure properly, do not purchase a time-based commitment, which is typically reserved instance in AWS world. And if possible, if you are a growing startup, prefer to go for a spend-based commitment and take spend-based commitment in a staggered manner. Go for 30%, then another 20%, then another 20%, something like that. Okay, so we have already covered three of them. Let's move to the fourth one. Cost arbitrage.
Adan, one
Yes.
question Karthik has asked on your earlier point. I think how often should we review our environment for idle resources?
Idle resources, what we typically, Karthik, first of all, that's a very good question. I think a lot of people get into that dilemma is that how often is too often and how often is too late, right? Typically, what we have seen is that weekly to bi-weekly cadence is a very, good cadence. You should do so. And we are going to talk about this in our cheat sheet also. For any kind of idle resources, you should do it ideally every week. If you can do it daily, that is great. But it is probably will not find idle resources on a daily basis, right? So it happens probably a week or something. But at least try to do it bi-weekly. A month is too late. Basically, what happens is that if you are doing every month, then something goes wrong and you still pay for the entire month. So ideally, my recommend would be every week. If it is too often, then do it every sprint. Typically, everybody does 2 week of sprint. So make it a sprint activity. Okay.
Yeah, we
Amber, do
can
we
move
have
on.
any other question?
No, we can move on.
Okay, great. So we are going to move on the next item, right? Cost arbitrage. And this is a very interesting fact, which is taking benefit of where you are located in the world, right? What happens is that if you are purchasing the exact same capacity of hardware in cloud platform across different regions and across different generations, the cost change, right? So what I mean by that, a few examples, for your awareness. A T3 instance, which is which is the latest class instance. AWS has also, released T4, but which is more focused towards Graviton. So T3 is typically the, latest generation, what we recommend. A T3 instance in Mumbai region is 7% more expensive than North Virginia, US East 1, if you are deploying that. So if you just deploy something in Mumbai, automatically you are paying 7% more, right? On the other hand, very interesting fact, a T3A instance, which is basically an AMD-based instance compared to Intel instance, if you are spawning up the same instance in Mumbai compared to US East 1, you get 50% cheaper. So just by identifying which region you are deploying your infrastructure, you can get a very big differences in your cost. So that is about the region. Now I'm going to tell you about the generations, right? AWS keep releasing new generations every few year, sometimes even more frequently. So T2 used to be the generation which was there few years back. Now they are moving to T3, and for Graviton they have also released T4. If you are moving from T2 to T3, you get flat 9% savings. Exactly. So the performance remains the same, the hardware remains the same, 2 core, 8 GB, whatever you are using. Just move from T2 to T3, you save flat 9%, right? So this is what I mean, and we have used this intelligently. Now, one thing I would highlight here is that it is not always flat, as you can see in our first example, right? So something is cheaper in Mumbai, whereas something is cheaper in US East 1, which is North Virginia. So you need to do this exercise very carefully. You can imagine how, the arbitrage fund in the, share markets work, right? So it's a very intelligent thing to do, but it is also a fine line, right? You need to do this very carefully. So, but the point is that you can take out savings out of it. So cost arbitrage is also something we have seen and we have applied across many of our customers. By intelligently moving their infrastructure, generation upgrade is almost always a no-brainer, because if you are running from your EBS volumes are Gen 2, you move to GP3, your EC2 is RT2, you move to T3, maybe in your let's say in your compute optimized, if it is M5, move to M6, things like that. If you are able to do that, you save flat money. And we have seen a lot of people miss that, right? So cost arbitrage is also, less often done, but is a very big opportunity for you to save money. Now let's come to your playbook, how you can do that. One thing we need to understand is that changing these kind of while generation upgrade is a little bit of easier to do, because you can always upgrade in place, right? You just need to identify a downtime, you upgrade. But region changes are not that easy after you deploy your infrastructure, right? So for example, once you deploy, let's say in US East 1, let's assume you want to now move to, hey, US East 1, I'm paying, let's say, 10% extra from Mumbai. Now I want to move from US East 1 to Mumbai. Don't do that, because when you are going to move your data along, you are going to pay for the data transfer charges. So a lot of cloud cost decisions need to be made when you are designing your infrastructure, right? When you are designing your deployment architecture, where I'm going to deploy, what kind of infrastructure I'm going to take. So if you are planning to play on cost arbitrage, it's always suggested that you plan for it. You cannot plan everything, but at least generation upgrade, always they are going to be new generation in the future. But at least for the region, you always need to plan for it during your deployment phase, while you are designing. Now, a couple of things we need to, we would strongly suggest you to do. One is you need to think about any kind of data residency, things which might be necessitated by your, by your industries. Like if you are in fintech, you cannot keep your data outside your the country you are operating, right? So even if there is a cost arbitrage because of the region, you cannot move the data. So that is a constraint you have. Beyond that, one other thing to consider is that where your end user is located. Sometimes I just cannot deploy my infrastructure in, let's say, US East 1, because it is cheaper, because all my 90% of my, let's say, end user sits in India, or let's say, Southeast Asia. So you are going to kick in the latency effect. So during your deployment phase, you need to think about what are the constraints you have during your deployment. Having said that, dev and test infrastructure, which is typically 30% of your overall cost, what we have seen across customers, that is something where you have more flexibility. So if you are, let's say, deploying in US East 1 compared to Mumbai, as long as you do not have data residency, it's a flat savings, right? It's a flat savings of 10%. And we have less dependency on latency issues and etc. in your dev and test environment. So plan that accordingly. It's a very nice way of saving at least 10 to 15% of your cost. Another one, very interesting thing, a lot of people miss doing this. Identify whether your application is CPU architecture, for example, CPU architecture agnostic or not. So whether you can run on ARM, class CPUs or not. If you are able to, then you might be aware of, let's say very popular, let's say instance class released by AWS, which is Graviton, which is the cheapest one they provide. So Intel is the most costly, then comes AMD, then comes Graviton, right? So the cost differs by 20-30% in each of these changes. So leverage that if you can. We totally understand that some of the infrastructure is CPU, let's say CPU bound. You cannot run them in ARM, or it takes you a lot of engineering efforts to move to ARM. Then do not do that, because 10% of cost savings is not worth it. But as long as it is worth, please take care, take leverage of the the cost arbitrage of it. Another thing which I mentioned, generation upgrade is no brainer. If you can do that, our suggestion would be is that to do this exercise at least once in a quarter, right? Every quarter, you should look at your infrastructure. Anything which can be upgraded to newer generation, please do that. Last one, before we wrap up today's webinar, we have spent let's say a good amount of almost 45 minutes. We are going to keep a good amount of time for Q&A. So let's talk about the last option, right? And this is where the beauty of cloud platforms come. If you look at any public cloud platforms, they provide plethora of options to you, what kind of infrastructure you want to use for your workload, right? A few examples. In virtual machine, you have general purpose, you have burstable, you have compute, optimized, you have memory optimized. In databases, you have the general purpose, you have the IO optimized. In storage, you have multiple tiers, hot tier, cold tier. There is a reason of why AWS has designed it that way, and we should leverage the benefit, the cost benefit of it, right? So if you understand your workload, we are going to talk about it more, how you should approach this. But by doing, optimized configuration for your infrastructure, what typically we have seen is that you can save 30 to 40% of your cost, right? What I mean by is that, let's say, if you are storing infrastructure, instead of storing everything in, let's say, in a hot tier, maybe can you move some of your, let's say, older data, infrequently accessed data into cold tier? If your, let's say, workload is memory intensive, you use less amount of CPU, but you are using a lot of memory. Can you use memory optimized instances? If you are, let's say, in the beginning, we talked about it. If you are using dev infrastructure, do you really need a general purpose? Can you do with burstable instance way cheaper than general purpose, right? So these kind of optimized infrastructure configuration, if you can leverage that, you can save another 30 to 40%. So now let's look at how you should approach optimized infrastructure, right? One of the biggest mistake we have seen in our customer is that doing optimizations without understanding your workload. Let me take a pause on that. These different kind of infrastructure options are designed for a purpose, right? So, compute intensive instances, if you see, they have a higher CPU to memory, ratio. If you go for memory optimized instances, they have a much higher allocation of memory compared to your CPU, right? Now, to leverage these kind of configurations, the first and foremost thing you need to understand is how your workload behaves, right? If you do not understand your workload, you are going to do these kind of optimized configurations. You are going to get into a cat and mouse chase. So what happens is that you optimize for something, then let's say, a week down the line, you understand that, hey, there is suddenly a spike which my infrastructure is not able to, handle because I optimized it too close to the usage pattern. So the first and foremost thing we always recommend our customers is that first understand your workload. Do you have too many peaks? Is your infrastructure the utilization is always consistent and predictable? When your, let's say, when your infrastructure goes, when the demand goes up, when the demand goes down, whether what is the utilization of CPU memory, how, if it is data, then how frequently your storage are being accessed. All these things you should start understanding in depth, right? Once you understand that in depth, then you are in a better position to identify what is the right kind of resources which can fit into. So you might be aware of some very famous examples and which keeps coming. Prime Video, they were running their entire infrastructure into serverless. One, fine day, they probably, struggled with, serverless infrastructure for quite some time, and eventually they moved everything into dedicated machines, right? Serverless did not work for their workload. Similar examples keep coming in our customers also. They opted for something, but eventually they understood that their workload does not suit that particular type of configuration. So first, our strong feedback, or let's say our strong suggestion always would be that first start with understanding your workload. Once you understand, then go for the optimization. When you are going for the optimization, you can first research on what kind of available options you have in mind. So if you are, for example, going, let's say, serverless as compared to dedicated servers, always do a cost projection first, that for your workload, if I'm moving to serverless, or if I'm moving to, let's say, less frequently tiered, let's say, cold tier storage or something like that, what is going to be my cost projection? So first do that and then move into it. A lot of cases, these configurations can be very overwhelming for small teams, and they have, let's say, whole lot of things to take care of beyond optimizing their infrastructure. You can always seek help, right? So there are professionals out in the market. We also are helping our customers with that. So feel free to seek help, either anyone like us who are advising how to optimize your infrastructure correctly. With that, we concluded the top 5 things we wanted to cover today. Before opening the floor for QA, I'm quickly going to talk about a cheat sheet, right? How you should approach your cloud cost problems so that you do not get into, let's say, these kind of frequently occurring issues, or places where you basically end up, paying more than what you should. The first and foremost, what we have seen across a lot of people, a lot of organizations we work with, and very honestly, this is not more of a technical problem. This is more of a process problem, right? Teams miss to track their cost and infrastructure regularly. I think, Karthik asked a very nice question: how frequently I should look at it? We always recommend to do it at least a week. Okay, so if it is too often, do it at least a sprint. You can make it a sprintly activity. Every sprint, at the end of the sprint, you can maybe, during your retrospective or just before closing your sprint, spend half an hour to look at your cost, look at your inventories. What are the infrastructure you have spawned up? Which one of them you are using? Is there any scope of optimizing them, right? So that is the first thing you need to do. You need to track and track your inventory and cost regularly. Part one. Second thing, super important thing. A lot of people says that cloud is a price, let's say, menu without a price tag, right? But it is a menu without a price tag until you give people a, let's say, price tag, right? So a lot of cases, what happens is that the teams are like, basically spawning off infrastructure in their, in their cloud platform without actually knowing how much they are supposed to spend, right? So, you can ask this question: how many of you have a awareness that, hey, how much, my team is supposed to spend this month or this sprint or maybe, this quarter for, let's say, for our entire cloud operations, right? If you do not have that, let's say, a number, ask your team lead or engineering manager, or maybe, your leadership team. If you are part of the leadership team, we always strongly suggest that always set a budget for your team so that your team knows that how much they are spending, right? How much they are supposed to spend every week or every month. So set a budget and track your spend. So it is more like a, we typically, educate all our customers this way, right? It is, think about it as your personal credit card. You're billing at your personal credit card, or it is your personal finance, right? In our personal finance space, we always compare our spend as against the spend limit or our bank balance, right? So it's a percentage. Hey, I spend 20% of my limit. I spend 40% of my limit. You should treat your cloud cost the similar way. Set a budget, spend, track your spend against it. One more, another important thing, we all are humans, right? We all make mistake. We spawn off infrastructure, in the evening, we had to run for, let's say, run for some work. We forget to shut them down, right? Or let's say there are things we every morning, let's say, there is a cadence of checking my cloud bill. One fine morning, I do not, check it. And, when you do not check it, then only the, like, those are the cases when all the instances, accidents happen, right? So very simple, let machine do the work. Automate your monitoring. You can leverage the default cloud capabilities. Cloud provides very, if you are operating on single cloud platform, you can leverage the cloud capabilities, setting up budget alerts, automating the start and stop of your infrastructure. You can, write your own Python function. You can, take up any of the open source tools, but automate the monitoring and execution of your cost optimization, strategies, right? Automate as much as you can. If your organization is already leveraging or thinking about getting a cloud cost optimization or a cloud FinOps tool, leverage their capabilities. These tools also provide, these kind of capabilities. So automate as much as you can so that machines have your back, right? Beyond that, two more things. This is more of a long-term strategy, but we, strongly suggest all our customers to do that. First, cloud cost optimization is not a one man's job or one team's job, right? If it only the DevOps team is doing cost optimization, DevOps team has a number of things to do, right? So they also have, places when they can miss doing things. The best strategy here is to divide and conquer, right? Involve as many people as possible. By as many people, I mean the engineers. So the people who are interacting with your cloud platforms, involve them into the cloud cost optimization exercises, right? So if you are a DevOps engineer, give access to cloud cost dashboards to your engineering team. If you are a leadership team, ask your DevOps team or your engineers to, build these kind of dashboards so that everybody has visibility on how what you are spending. And if you are an engineer, then take it on yourself, right? You can own the cloud cost optimization exercises. You can bring up these kind of suggestions. You best understand what you are running, right? You own your infrastructure. So bring this collaborative ownership culture in your team so that everybody can contribute. Everybody has each other's back, right? So if DevOps team is missing something to take care of, engineering teams can do it. If engineering team is missing something to do that, DevOps team can do it. If everybody is missing, leadership team is looking at those dashboards. So something goes wrong, they can, they get alert. So bring, we always suggest our customers to bring a, let's say, a collaborative culture of cloud cost optimization so that everybody can collaboratively avoid these kind of cloud cost accidents. And the, last and but not the least thing, cloud cost accidents, as I mentioned, a lot of cloud cost decisions are much more costly to change when you go to production, right? So whenever you are designing your infrastructure, whenever you are building your let's say cloud architecture, always bring cost as a factor. Whenever you are introducing a new service, whenever you are choosing your infrastructure configuration, always bring a cost perspective of it. Do a, let's say, rough calculation or let's say projection of how much this is going to cost. And one interesting fact what we have seen often is people miss calculating their data transfer cost, right? If your architecture is distributed, you are going to pay for data transfer cost, which can go up and down, right? If you have a huge amount of people accessing your infrastructure, you end up paying a lot of money from data transfer cost. We are going to do a separate webinar on these kind of topics, specifically how to design your architecture in a cost optimized way. We are going to talk more about that. But whenever you are designing within your team, always bring a cost factor into it. Always check that whether my architecture is cost optimized or not. With that, I'll just quickly repeat one more time. This is your cheat sheet from our side. track your inventory and cost regularly, set up budget, let everybody know how much they are supposed to spend and let them track their spend against it. Automate as much as you can so that machines have your back. Involve everyone, build a collaborative FinOps culture within your organization so that everybody can collaborate and avoid cost accidents. And last but not the least, cost is a super important decision during your design phase. So talk about cost. If no one else is talking about it, you raise this point that, hey, what about cost? Is this the most cost optimized architecture or not? With that, I'm going to take a pause, and before we we are going to open the floor for QA. But
One question,
yeah,
Tanu,
yeah,
already.
please.
Again, Karthik asking, very nice
Yes.
question. May I know a large Azure environment with heavy use of VMs, AKS, and SQLDB, how would you optimize cost while maintaining performance and scalability without impacting SLAs? What specific measures would you recommend?
Okay. Very nice question, Karthik. So as I mentioned, whenever you are doing any kind of optimization, there are two, one most important thing you should always start with, which is the, understanding your workload. So why I mentioned that is because, giving a very generic answer without understanding your workload is, absolutely wrong. I don't want to do that. Having said that, a few things I would, definitely recommend. First is that you should always make sure that you mentioned you are using a lot of VMs, right? And we very commonly see that, whenever people are running on bare metal infrastructure, it is not serverless. So serverless is on demand. Your usage goes up, your cost also goes up. But, whenever you are using VMs, those are provisioned capacity. So always make sure that all your infrastructure are right sized. Do the right sizing again based on your workload. Do not do it only for your average utilization. Also look at your peak utilization and how often you do see those peak utilization, right? Is it only once a month? Then probably that's an anomaly. Is it happening every day? That's not an anomaly. That's a pattern. So you should plan for your peaks, right? So right sizing is one of the thing. Same thing goes for databases also. AKS is a very interesting topic. AKS, we have seen people leveraging different kind of, let's say, whenever you are going into AKS, then you get the entire capability of the auto scaling, right? We have seen we designed one of the let's say auto scaling architecture where we leveraged spot instances heavily behind the scene for AKS for one of our customers. So that is one of the strategy, and these are strategic optimization we do for our customer, where we design a very specific solution for our end customer depending on their workload. But and I'm pretty sure there will be some opportunities for you as well. Happy to talk about it at a later point. Maybe we can catch up. But on a generic basis, few things I would strongly suggest: right sizing, as we talked about it. Generation upgrade. If you are using any kind of older generation infrastructure, make sure you upgrade them. So these are the two things you should definitely do.
I'll add one aspect to it, right? So every organization is different, right? What we are kind of talking here are general principles which probably are applicable to 80-90% of the organizations. For you, Karthik, it will depend on your setup, your organization, your workflows, your working hours, your workload, and depends on time as well, whether you are e-commerce, fintech, healthcare, right? So it will also depend on your situation. But yeah, one more question, this time from Deepak. For QA environments, how do you track who's accessing at what time, and accordingly, how will you determine when to turn it off?
Okay. Again, very nice question. And there are a couple of strategies for it, right? So this is something, as I mentioned, idle resource management is a very interesting fact, and this can be done a few ways. I'll take your first question first. Who is accessing your infrastructure? This is something I'm not sure. Probably you can mention it in a follow up. Is what you are trying to track, whether the app level access or the infrastructure level access. If it is an app level access, that who is accessing my QA infrastructure, you should do it at your let's say gateway level, right? So if it is a API driven architecture or microservice driven architecture, you can do it at the gateway level, that hey, who is authenticating with these users or things like that. If it is purely on the cloud side, ki, hey, who is accessing, who is SSHing into this VM, then there are customized solutions which can be built. More generically, you can use CloudTrail to understand CloudTrail in terms of AWS. You can understand who is basically accessing or interacting with that application. Again, as Amber mentioned, largely depends on what is your, I always suggest that, you should always start from the goal, right? What you want to achieve by tracking, who is logging in. Depending upon that goal, we can come up with a very different. So, cloud trail tracking can be very efficient for a certain kind of goal, whereas app level tracking can be a very different, let's say, strategy. So it depends on your goal. So we should always start with that. I'll come to your second question, when we should start and stop. I think this is something typically what we recommend our customers is that it depends on the team practice, right? Typically, it is QA environment, right? QA or dev environment. So you need to understand when the large part of your team is working in, right? So, and we have seen a lot of people starting, let's say, 9 a.m. in the morning, then go till 8 p.m. in the morning. Sorry, 8 p.m. in the evening. So that is the time these infrastructures are being utilized. You can do two things. One thing we also did for one of our customer is proactive optimization. You can imagine, right? So the very first thing in the morning after logging in, you do not enter, you do not always log into your QA environment and start doing testing, right? So, in one of our cases, what we did is that the team proactively took up a schedule where they are going to utilize their infrastructure, right? So they scheduled that, hey, we are going to run our infrastructure from 10 to 6, and all the activities will be done within that. And they scheduled their meetings and all the other collaboration things beyond this window. So this is something, again, agreement you can do within your infrastructure. But otherwise, if that is not possible, you can very simply look at the utilization pattern. When is your infrastructure is sitting idle, and accordingly you can automate that. One last thing, even if you are automating the starting and shutdown, I would always suggest to keep a, let's say, backdoor or let's say, shortcut, so that in urgent situation, if for example, let's say something has gone wrong and your QA need that environment to test, always keep a, let's say, backdoor so that they can manually start things up. So that would be my suggestion.
Correct. Correct. So not always the solutions are technical. Some of them are, mutual agreements between teams. As Atanu mentioned, you need to agree
Yeah,
with probably the testing team, identify their work pattern, and
yeah.
then what happens nowadays, right? Because the data is huge, right? Even the test environments are become very bulky. So, I mean, it's difficult to give them as much freedom as we'll want to, right? So, uh, thanks, approach about session. Yeah, great session. Thanks, Deepak. Rushikesh has asked a question. If we want to set up a monitoring for our client server, how can we implement it in cheaper way?
Great,
Currently, it
great
is
question again.
based
And
in
these are
ALK
like,
stack.
sorry, Amber, sorry, what was that?
Currently, it is based on ALK stack.
ELK stack. Great. So, okay, before we take up that question, Amber, what I was thinking is that maybe we can, whoever has a question and maybe, you might be joining from mobile and not in a situation to type. So you can always raise a hand. We can unmute you and you can simply ask the question. So feel free to raise your hand as well. Okay. So coming to your question, this question was from Rusikesh, right?
Correct.
Great, great question, Rusikesh, and I'm super happy that you guys are asking, super relevant questions, core pain points what engineering teams see, right? Okay, ELK stack is a very interesting thing. I'm not sure whether you are self-hosting it or you are using. So ELK stack has three different options, right? One, you can self-host it. Second, you can use for let's say the managed services by AWS, and then you can go for their cloud offering, which is given by Elastic. Elastic offering is the most flexible and the most capable one and the most costly one. I'm just giving you the, the whole picture here. We have used ELK stack very closely before. So the Elastic Cloud is the most expensive one. Then, the AWS one is a little bit cheaper than that, but this is still expensive. And you do not get the exact Elastic because, AWS basically does the open source one, open search, not the, Elastic search one. And then you can always the self-host. You can either, get their license, or you can also host the open source version yourself. The management overhead goes the other direction. So the way you go cheaper, the overhead will come, on the other direction. So the self-hosting, you will get the cheapest option, but Elasticsearch clusters are, super famous for going down. Your node will go down. You have to go, do a lot of, monitoring on top of it when your nodes are going down, and take things accordingly. One suggestion I will give is that if you have flexibility, consider other options as well. If you already have not started it, Signos is coming up as a very strong competitor these days. A lot of people are leveraging them, entirely open source. They also do have a cloud version, but they are a pretty nice monitoring stack. I am again not exactly sure about from the when you say Elasticsearch, I'm assuming you are using it as a log solution as well, right? So if you are thinking about the log solution, you can also leverage, let's say, Grafana and let's say, the Loki, their, log solution as well. So so to summarize the entire thing, when you are talking about the cheaper option, I think it would depend on how much management overhead you can take, whether you have, let's say, people to manage self-host it, because that is going to be your costly, cheapest option. But you are going to be bogged down by a lot of management activities. So take a decision accordingly. Managed services will be always cheaper. AWS, ELK stack, their managed services is a fair deal between both worlds. They will manage it for you, but the cost will be a little bit higher. The best part, if you can do it, and if you still want to stick to self-host and open source, also consider any other solution as well. These Signos and everything, also they provide cloud options, and this is also something will be influenced by your architecture. Can you let your data out of your let's say network, right? If you are using any kind of third-party SaaS, for example, let me take an example. You are using New Relic, right, which is another competitor of ELK stack, or you are using Datadog. If you are using their cloud platform, your data is going to go outside your, let's say, your boundaries, right? So you need to take all those considerations out and take a decision accordingly. Again, if you need help, happy to, talk about that.
Then can you cover the next two slides? There probably will be a few more questions.
Yes, sure. So, team, before we, let's say, before we are going to talk about few more interesting challenges and all, I quickly wanted to touch upon, let's say, we started with our history. We started the journey of Clofio in pursuit of helping small, organizations of all size, help them optimize cost, right? That has been our motto from the beginning. So I just wanted to talk about a very specialized service we are bringing in for everyone. We call it the COAS, which is cost optimization and service, and we are exactly helping our customers with these kind of questions, right? We bring in and curating the knowledge of what people are doing wrong, how they can make their situation better, and how they can optimize cost. So the goal of this particular service we are offering to our customer is specifically work closely with your team to understand your challenges and design a cost optimized architecture, right? We work very closely with your team. We identify what works for your workload, your infrastructure, not a generic solution, right? And the best part of it is that we work on an outcome based model. So we are going to charge you money only when we save you money. So, that is something I just wanted to present. So if you are in lookout for any help in your cost optimization journey, or a friend or acquaintance who are looking for help, we are here, happy to help you. Just drop us an email on hello@clofio.com. We will also share our LinkedIn page. So happy to connect and talk more. With this, I'll again open the floor for QA. This is our QR code. You can scan and follow our page. You will also get our, LinkedIn, let's say, contacts here on that page. We are bringing in more webinars in this series. As I said, the next webinar we are going to bring in is about how to read your cloud bills, right? Cloud bills are super famous to be complex, right? A lot of people complains about, hey, I do not understand why my cloud bill is going up, how they bill me. So we are going to do a tear down of an entire cloud bill and tell you how to read your cloud bill, right? How to understand how they are charging you. So that's our webinar. Follow our page. We are going to make a post as soon as that webinar comes up, and happy to talk about it. Again, looking forward to more questions and discuss more. Please raise your hand if you want to directly talk. Amber is going to unmute you.
Yeah. Yeah, Rajkumar has already asked a question regarding AWS APIs. Are there any APIs to give billing information, granular information specifically?
Yes, Rajkumar, there are APIs. There are Cost Explorer APIs, which gives you pretty good yeah, details of, let's say detailed data of your cloud bill. But there is a problem. The problem is that every time you call that API, they charge you 1 cent. So if you are doing this based on your APIs, make sure that you pull as much data as possible at one go, and then you analyze that data at your side, your app side, right? You do not do it directly by calling their APIs a lot, because then you are going to get a lot of bill just because while analyzing that bill. So that is something strongly discouraged. But if you can pull a bulk data out of that API call in a single call and just analyze it, feel free to do that. Another interesting way of doing it is that in AWS, you can, export a cost export, like the way they basically bill you. They do the entire dump of it in S3, right? So if you are building an automated solution or any kind of, let's say, cost analysis, you want to do it in-house, a much better strategy is to configure this dump in your S3. Then you can call your S3 API, get that CSV out and analyze on top of it. So it is still going to be an automated solution, still API-based solution, but it is much cheaper, and you can basically, do a lot of things and avoid, 1 cent per call.
Super awesome answer. 1 cent per call sounds very expensive already. Okay,
Yes.
Jigisha has asked a question. We are incurring high data transfer costs. Any suggestions for that?
Very interesting question. As I was mentioning, a lot of people while designing their architecture, they project for their compute cost, they project for their storage cost, but data transfer cost is hard to, estimate, right? Because until you get load on your system, you really do not know how to, optimize your data transfer. But one thing, you first need to, and we are going to do a follow-up webinar on this, specifically on the data transfer cost. But few things you need to see in your architecture. Part one, where exactly you are going to, you are incurring the data transfer cost. And this is something, again, we are going to do in our webinar, how to read your cloud bill and figure out where the data transfer cost is coming in. There are few different ways of you get data transfer cost. One is your outbound cost, your data going out to internet, part one. Second, inter-region cost, your data going from one region to another region. Third is the inter-AZ cost, your data going between one AZ to other AZ, which is availability zone. So while you are designing your architecture, you cannot entirely avoid it, because a bigger organization always would like to have, let's say, redundancy. So you will distribute your architecture across, across availability zone, across regions. But while you are doing that, you need to make sure that your application does not, your application is not very chatty, right? Whatever data you are sending across region, or let's say, across AZ, you need to understand whether there is a way of reducing it. Again, it is very much tied to your application. There is no thumb rule, because if you are just every call you are sending a whole bunch of data in your each API call, you are going to cost a lot of money. So data transfer cost in large part is optimized by your application architecture. So you can analyze your cloud bill, try to identify where the chunk of that data is coming in, and optimize accordingly. Do we have more
Okay.
questions?
Any other question? One common question, Atanu, I get from the customers that we connect with is how to select which cloud to go with, right? If we have to just rely on cost, which ones do you think are most efficient from cost point of
Very
view?
interesting
AWS,
question.
GCP.
Yeah, I think that is something like startups, when startups are starting their journey, it's a very very common question, and people try to understand, hey, whether I should go for AWS, GCP, or Azure. Uh, each cloud has their benefit, right? And their pricing are also comparable. And you can imagine, right? These people are competing in the market. So obviously, AWS is not flat cheaper than Azure. That it doesn't work. But when you are deciding for your cloud platform, I would strongly suggest two things to take that decision. Part one, go for your skills instead of your cost, because if you go, let's say, let's assume AWS is far cheaper than Azure, but you do not have any understanding of AWS because all your engineers has been working their entire life on Azure. So you are going to spend much more time and energy, basically human cost, right? In learning, in training, people making mistake. You are going to spend much more invisible cost rather than saving your cloud bill, right? So I always suggest our customers is that when you are customers and the startups we mentor, whenever you are going for a cloud platform, first identify your strong point, right? If you are, let's say, strong in AWS, go for AWS. If you are strong in Azure, go for Azure. Within that, you can basically identify what goes, let's say, really optimized. Another thing, if you are designing a very specialized solution, right? Very specialized, I mean, like, a very large architecture, there are cases where there are comparable solutions. For example, like, I'll give you one thing. Like, you are trying to do a NoSQL solution, right? So in NoSQL, you have, let's say, MongoDB Atlas, very famous. Then, Azure provides their own NoSQL solution. AWS provides DocumentDB. So if you are specifically building something which at a huge scale, at that time, it is like, you can basically do a comparison of all these different cloud platforms. But that too also comes like, that decision gets driven by the, features you need rather than the cost. So cost is never the first consideration. Always, like, if it is a human decision, go for your skills. If it is a technology decision, go for what you need, then identify what tool you need to choose.
Perfect. In fact, this question was so often that we eventually built a page. So if you search Clofio free tools, we have built a free tool to compare the three crowds, as well as, let's say, if you want to build a small infrastructure, let's say of 4 CPUs, 8 cores, X amount of RAM, we can quickly the tool can quickly calculate and give you the amount based on the cloud you choose, cloud region and service you choose. You can try that out. Any other questions, team? Otherwise, we can conclude. Super awesome audience today.
Excellent. I think we are on the top of the time
Yes.
already. So 13 minutes left. So what we are, if we don't have any other questions, we are, so let me just move this. So very much thanks for everyone to be a very wonderful audience today. We are going to give you, 10 minutes back in your calendar. If you have any other discussions you want to have, you want our opinion, or you are running a, let's say, cost optimization exercise and want us to engage. So feel free to write to hello@clofio.com. You can also find Amber and me on LinkedIn. Just, search for Amber Clofio or Atanu Clofio. Feel free to send us a connection request. We would be super happy to, discuss more. As I said, we are, please also follow our, let's say, LinkedIn page if you haven't done that already. We are going to come up with more webinars in this series. We are going to talk about how to read your cloud bill. Jigisa asked the question about the, data transfer. We are also going to do a more focused session on that as well, how to design your cost optimized architecture. So, tune in. As soon as we have more things, we'll drop, let's say, that news in LinkedIn. Super happy to be part of this webinar. And thanks the entire Clofio and Cloud Mahut team for organizing this. And thanks to everyone for joining us today. Looking forward to discuss more. Feel free to reach out if you have further questions. Thank you.
Thanks, attendees. Thank you. Thank you all.